All right, so the point is we want to find the slope of the tangent line at point A comma f of A. We drew this tangent line. This is a line colored as black, and slope of the line needs 2 points. So we are going to draw instead a secant line passing through A comma f of A and x comma f of x. So this point is x, and this point is going to be x comma f of x, where x is any point. Now, what is the slope of the secant line? So the slope of the secant line is going to be f of x y2 minus y1. So f of x minus f of a over x minus a. Yeah. Now, however, we wanted the slope of the tangent line. So for that, notice that if x goes closer and closer to a, what will happen? So if your x goes closer and closer to a, your secant line will become tangent line, right? So therefore, you get limit as x goes to a of f of x minus f of a over x minus a is slope of the tangent line at a comma f of a. So this is what the slope of the tangent line is. We can rewrite the same thing as follows. So if your x, so if this distance is h, or the difference between a and x is h, then we have x equals to a plus h. Yeah, note that h can be positive or negative depending on which side of a your x is. In that case, we can rewrite the whole thing as f of x would be a plus h minus f of a divided by a plus h minus a, limit as x goes to a. So now let's see, what does it mean by limit as x goes to a? This means if x goes to a, that means x minus a goes to 0. But x minus a is equal to h. So that is same as saying h goes to 0. So we'll replace this limit by limit as h goes to 0. And then that you can rewrite as limit as h goes to 0, f of a plus h minus f of a over h. So this limit, of course, if it exists, is the slope of the tangent line at a comma f of a. All right. So this is how you find out the slope of the tangent line. Okay. Now let's do the following problem. Find the slope of the tangent line to the graph f of x equals to x cubed at x equals to 1 and x equals to 2. So what is the slope of the tangent line at f of x equals to x cubed at x equals to 1? So here, the slope of the tangent line at x equals to 1, the slope will be given by limit as h goes to 0, f of 1 plus h minus f of 1 over h. That is going to be limit as h goes to 0, f of 1 plus h is going to be 1 plus h the whole cube minus 1 cube over h. Now you need to simplify it. So either we can use a cube minus b cube formula. So what is a cube minus b cube? It's a plus b times a square plus a b plus b square divided by h. This is going to be limit as h goes to 0. This one and this one will cancel, so you have h over 1 plus h square plus 1 plus h times h plus 1 square, the whole divided by h. Right? Now, this h and this h will cancel. Yes. And then what do we get? We get this is equal to, as h goes to 0, of 1 plus h square plus 1 plus h times h plus 1. So let's see, what do we get when h goes to 0 here? Sorry, this is 1, right? So we get, this is going to be 1 square plus 1 square plus 1 square, which is going to be 3 times 1 square, which is going to be 3. So the slope of the tangent line to the graph is going to be 3. Now, can you work out same way for x equals to 2? So at x equals to 2, the slope of the tangent line is going to be what? Limit as h goes to 2, sorry, h goes to 0, f of 2 plus h minus f of 2 over h. Of course, provided that this limit exists, and you will see the limit does exist, and you will get this limit to be 3 times 2 square, which is 12. Okay. So now, what is the equation of the tangent line at those points? So let's see. So what is the equation of a line? So if x1, y1 lies on line L, slope of line L is m, then equation of tangent line is y minus y1 equals to m times x minus x1, right? So now at this point you have already found out. So at x equals to 1, what is the point? The point is point of the tangency, or point of on the line is 1 comma f of 1, which is going to be 1 comma 1 cube, which is 1 1, and the slope m is 3. So therefore equation of the line, the tangent line, is y minus 1 equals to m, which is 3 times x minus 1, right? So this is the slope of tangent line at 1. We found out the equation of line to be 3 times x minus 1. And now if you look at this here, this graph here, so we already have found out the equation of tangent line to y equals to x cube at 1 1 is going to be y minus 1 equals to 3 times x minus 1. And you can see that graphically that this is what is happening. All right. So does that make sense? Yeah. All right. So let's go back. So similarly, you can check that if you, for at x equals to 2, the point is The point on the graph is 2 comma f of 2, which is going to be 2 comma 8. As the slope is already 3 times 2 square, we found out that to be 12. Therefore, the equation of line is y minus 8 equals to slope times x minus 2. And again, you can see this from the graph that I have 12 times x minus 2. So y minus 8 equals to, and this you can see that here it's tangent at this point. All right, so you see the red one is the graph of your function and the blue line is the tangent line, and you see that they are somewhere around here. They are, that the line is tangent to the curve. It's not very clear from here, but you can see that this red line is red graph and blue line are somewhere tangent here, right? There's small amount of red shade here. So we have graphically seen as well that we get the right tangent lines, and it should be the case anyway. So now let's do the following problem. Find the slope of the tangent line to the curve y equals to 1 upon square root of x at x equals to a. So let's do this problem. So in this case, your f of x is 1 by square root of x. So now either you can compute it either way. Limit as h goes to 0, f of a plus h minus f of a over h, or you can compute it as limit as x goes to a, f of x minus f of a over x minus a. Yeah, either way is good. So let's see. So I'll use the first one here. So limit as h goes to 0, f of a plus h. So f of a plus h is going to be 1 by square root of a plus h minus f of a, which is 1 by square root of a, divided by h. So this is going to be limit as h goes to 0, cross multiply. So we need to, so if you put h equals to 0 on the top, you will get 0 and 0 in the bottom, right? So we need to cancel out some common factor, and that factor is going to be h minus 0. So let's simplify this. So cross multiply, and this will come in the denominator, a plus h times square root of a multiplied by 1 over h. I'll keep 1 over h on the side. Now, we can rationalize this again because we need a factor of h on the top. Yeah. So let's rationalize it. So limit as h goes to 0, square root of a. So how do you rationalize a square root? You multiply by the conjugate, and the conjugate in this case, note that the conjugates are different when you have to raise to different powers. But if you have to square it, the conjugate is, if this is a minus one, minus sign in between, if you have a minus sign in between, you have to multiply with the same thing with the plus sign. That depends on a, this relies on the fact that if I want to square these two guys, I'll multiply it with what? I'll multiply it with a plus b, because that's what you get, a square minus b square. That's how you get a square minus b square. So I'm going to do that multiplication on top and bottom. So this is going to be limit as h goes to 0. So a square, so square root of a, the whole square is going to be a minus b square, which is going to be this, times what? Square root of a plus h times square root of a times square root of a plus square root of a plus h. Now I can cancel these guys off. This gets cancelled with this guy here. There was a minus sign, so this should have also changed to minus sign, right? And this goes minus 1 times, and the h goes, there was a h in the denominator. So in the end, when you take limit as h goes to 0, what do you get? You get minus 1 over, as h goes to 0, you can substitute now h equals to 0. You get square root of a times square root of a. So square root of a times square root of a times 2 times square root of a. This is going to be minus 1 by 2 square root of a to the power 3. And if you want to write the same thing in a different format, slightly different format, you can write it as 2a to the power 3 over 2. So this is your slope of the tangent line, right? Now it's asking you to find out what is the equation of tangent line at 1, 1. So the equation of tangent line, after all, it's a line. So we already know, so let's check whether 1, 1 lies on this graph, and it does. When x is 1, you have f of 1 is 1 upon square root of 1, which is 1. So this guy lies on the graph, this point lies on the graph, and what do you get? You get y minus 1 equals to m, in that case, m at 1, at a equals to 1. What is my m? My m is going to be minus 2 by minus 1 over 2 by, times 1 to the power 3 by 2, which is going to be minus 1 over 2. So what do I get? Y minus 1 equals to minus 1 by 2 times x minus 1. So this is your equation of the tangent line at that point. So this gives us the most important definition of the course, which is the derivative. So derivative is the slope of the tangent line at a given point. So derivative at a point A, number A, is the slope of the tangent line at that point A when you draw the graph. So if we want to forget about the geometry here, the geometry of being tangent line, we can define derivative to be f prime A is limit as h goes to 0, f of a plus h minus f of a over h. Now, since we have seen cases where limit does not exist, we should say that provided that this limit exists, we have the derivative at that point. If this limit does not exist, then we do not have derivative at that point. Okay. So let's do the following. So because we know that this limit is same as limit as x goes to a of f of x minus f of a over x minus a, we can either use this to compute the derivative, or we can use this one to compute the derivative. Either one is okay. So now let's do the following problem. Find the derivative of the function y equals to 1 upon x minus 1 at x equals to 3. So same object renamed now. We will basically find out the derivative at 3. So we should find f prime of 3. And that by definition is limit as h goes to 0, f of 3 plus h minus f of 3 over h. So this is going to be limit as h goes to 0, f of 3 plus h is going to be 1 upon 3. Wherever there's x, I'm going to put 3 plus h. So I have 3 plus h minus 1. F of 3 is 3 minus 1 over h. This is limit as h goes to 0, 1 by 2 plus h minus 1 by 2 over h. This is going to be, now we need to simplify this. We need to cancel common factor of h from top and bottom. So we cross multiply So this is going to be 2 minus 2 plus h. So 2 minus 2 plus h multiplied by 2 plus divided by 2 plus h times 2 times h. Now when you open this bracket, this 2 and this 2 will cancel, and this minus will make h as a minus, give h a minus sign. So we get limit as h goes to 0 minus h over 2 plus h times 2 times h. Now you can cancel these guys off, goes minus 1 times, goes 1 time, and now as h goes to 0, you can see that this is going to be minus 1 over 2 times 2, which is minus 1 over 4. Okay, so minus 1 over 4. So this is the derivative at this point. Note that this is also the slope of the tangent line at that point. Okay, same things, two different labels. Now, can you basically think about what does this limit represents? As some of you said, this can be rewritten as limit as h goes to 0, 2 to the power 3 plus h minus 2 to the power 3 over h, and this can be seen as f prime at 3 for f of x equals to 2 to the power x. All right, so this is the derivative of it. Now, let's look at the next one. F of x equals to absolute value of x. Does f prime 0 exist? So what does it mean? It means we have to basically find out this limit. So f prime 0 is this limit here. F of 0 plus h minus f of 0 over h. This is going to be limit as h goes to 0. What is f of 0 plus h? Is going to be f of h, which is going to be absolute value of h, minus f of 0. So let's ignore that. So because why are we ignoring it? Because it's 0. So subtracting 0, we can ignore to write that. Now let's find out this limit. So we simplify this to find out the limit. There is an absolute value sign. So the absolute value depends on absolute value of h is h if h is positive, and minus h if h is negative. So we can basically try to look at the one-sided limits. So limit as h goes to 0 plus of absolute value of h over h is going to be limit as h goes to 0 plus h over h. Why is that? If h goes to 0 plus, h is greater than 0. So this would imply absolute value of h is equal to h. So in that case, we get, so h over h, which is going to be 1. Similarly, if you look at the left-hand limit, we get absolute value of h over h. That is going to be, now if h goes to 0 minus, that means h is less than 0. And this would imply absolute value of h is minus h. So we get limit as h goes to 0 minus of minus h over h. And when you cancel out the common factors, you get minus 1. So now you see the left-hand limit and the right-hand limit are not equal at 0. Therefore, limit as h goes to 0, absolute value of h over h does not exist. Why is that? Because since left-hand limit is not equal to right-hand limit at x, or at h equals to 0. So this limit does not exist, and hence this derivative does not exist. Okay. So, all right. So now let's since we found out that the slope of the tangent line is f prime a, therefore the equation of tangent line can be rewritten now. The point is a f of a, slope m is f prime a. right? So therefore, the equation of line is going to be y minus y1, which is f of a, equals to slope, which is f prime a, times x minus a. So this is how the slope of the tangent line looks like. All right. Now, can you find the equation of tangent line to f of x equals to 1 upon x minus 1 at x equals to 3. So again, so here you have x is 3. So point is going to be what? X comma f of x, right? So which in this case is going to be 3 comma f of 3, which is 3 comma 1 minus 3 by 2. So it's going to be, so 1 minus 3 minus 1, which is 1 by 2. So this is your point. And now let's find out f prime of 3. So please go ahead and find f prime of 3. So f prime 3 is going to be limit as h goes to 0, f of 3 plus h minus f of 3 over h. Yeah, but we have already computed this limit earlier on here, right? So that limit turned out to be what? Minus 1 by 4. So your f prime at 3 is minus 1 by 4, calculated earlier. Therefore, what do we get? Therefore, equation of tangent line is y minus f of 3 equals to f prime 3 times x minus 3. So y minus f of 3 is y minus 1 by 2 equals to 1 minus 1 by 4, which is a value of your f prime 3 times x minus 3. So this is your equation of the tangent line. You can leave it at that. Okay, so now consider the following. Compare the derivatives of the points, derivative at each points of the function. So can we try to compare the derivatives here? So consider from here, from this part to this part. So let's draw. So derivative is the slope of the tangent line. So let's draw the tangent lines and see what do we get. Yeah. So this is how the tangent line will look like. At this point, the tangent line will be, and at this point, the tangent line is going to be, at this point, the tangent line is going to be. Okay. So now let's compare the tangent lines at this point. So at this point here, what is the derivative? Derivative is the slope of the tangent line. What can you say about the derivative? Is there any information you can get out of this graph for the derivative? So it's the slope of this tangent line. And what is the slope? Is it positive or negative for this line? It's what? Positive, right? Why is that? Because there are two ways to look at that. So if this angle is theta, then tan of theta gives you the slope of the line, right? So here tan theta is positive. That's one way to look at this. Another way to look at this is if you look at rise over run. So let me look at rise over run. So rise over run. So rise is positive. So this is your rise and this is your run. Run is also positive. So if you divide two positive quantities, you get positive. Same way here as well. At this point, for this line, if you look at rise over run, it is positive. So the derivative is f prime x is positive. Here f prime x is also positive. Now, what about this point? The tangent line is horizontal, so the derivative, which is the slope of the tangent line, is 0. Here, if you look at this guy, then you will see that rise over run is negative, or if you look at the angle theta, that is bigger than 90 degree, and tan of angle bigger than 90 degree and less than 180 is negative. So here f prime x is less than 0. Yeah. So later on we'll see if the derivative is increasing, sorry, if the derivative is positive, that is, it hints on the following, hints on, of course, this is not a proof, hints on f is increasing implies f prime is positive. So f is increasing at a point or in an interval, then the derivative is positive. So f is increasing on an interval, right? So your function is increasing from this interval to this interval, right? And you can see at all these points the derivatives are positive. And f is decreasing on an interval if f prime x is less than 0 on that interval, right? So